So good morning. Our bell work today was to fill out the table using the given function and to sketch a graph. So the function that we were given is f of x is equal to x squared plus 2x minus 4. Okay, so this is a little bit of review for Algebra 1, maybe a little bit of Algebra 2 as well because that square is in there, but you guys do know how to square things, so you should be able to get there. Okay, so what's true about every number that we square? What's the outcome of all squared numbers? It has to be this specific type of number.
The sigma type.
Sigma type. Okay, so if I do a negative times a negative, I'm always going to get a positive.
If it's a negative times a positive, it's always going to be a negative.
It's always a negative. But if we square something, is there ever going to be one negative and one positive?
No.
It's always going to be the same sign, right? So no matter what, when we square something, it's going to be positive. Okay, so I'm going to go straight to my camera here. Okay, so the first one we want to try is f of x, f of negative 2. So we plug in negative 2 for our x, so we have negative 2 squared plus 2 times negative 2 minus 4. Okay, and at this point, if you were to put this in your calculator without the parentheses, you're going to get a incorrect answer. Because when you do negative squares in a calculator, so this is in a calc, short for calculator by the way, when you do negative 2 squared, what it does first is it does the exponents, right? Because the orders of operations, exponents always go first. So it's going to do 2 squared, which is 4, and it will do that first. So you're going to get a negative answer instead on your calculator. So in your calculator, please, 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 always put the parentheses around your negative number. Okay, so negative 2 squared is positive 4. Positive 2 times negative 2 is negative 4. And then we have that minus 4. So we have that when x is negative 2, we get 4 minus 4 is 0, minus 4. So this will be negative 4. Nice. Okay, now let's go ahead and plug in f of negative 1. Oops, I didn't need a double parenthesis, but I'll just put that there. It was an accident. Okay, so negative 1 squared plus 2 times negative 1 minus 4 will be equal to 1 minus 2 minus 4, which is equal to negative 5. Interesting.
What are you yapping about?
Huh? I'm doing algebra right now at the moment. I'm plugging in the x's, right? I'm plugging in the x's into this function, and I'm getting my output value. Okay, and you got the same answer, right? So negative 4, then negative 5. Okay, so now we want to plug in 0 and see what we get. Well, when I plug in 0, 0 squared is 0. 0 times anything is 0. So all I'm going to be left with is negative 4. So I know I'm going to have a negative 4 right there. Okay, now we're at positive 1. So f of 1 is equal to 1 squared plus 2 times 1 minus 4. 1 plus 2 minus 4 will equal negative 1. Because 1 plus 2 is 3, minus 4 would be negative 1. So at 1, we're at negative 1. Okay, and now let's do f of 2. So f of 2 is equal to 2 squared plus 2 times 2 minus 4. 2 squared is equal to 4. 2 times 2 is equal to 4. 4 plus 4 minus 4 is just 4. So our f of 2 is equal to positive 4. Okay, so we got our table filled out. If your table doesn't look like this, please try to match mine, okay? If yours does, raise your hand if your table is able to look like mine by the end of this. Okay, so please go ahead, if you didn't put your hand up, get yours changed to look like mine, okay? So now let's go ahead and provide our sketch. Okay, a lot of people did not do this on their bell work, so I need this as well, please. This is how we sketch any type of graph anytime we're going to get a sketch. Okay, so here's our x and our y. We always want to label our x and y axis. Okay, and then I'm looking at my table, and all my numbers are between like -5 to +5. So that's where I'm going to make my boundaries of my graph. So I'm going to go positive 5, 1, 2, 3, 4, 5. Negative 5, 1, 2, 3, 4, 5. Positive 5 on the y, 1, 2, 3, 4, 5. And positive or negative 5 on the bottom, 1, 2, 3, 4, and 5. Okay, so please sketch your graph to look like this. Chase, you already there? You already have that. Awesome. Okay, and now I have all of my points, right? Right here I have an x and a y, so I have my points that I can graph. So for my first one, I have -2, -4. So I'm going to go back -2, so count left -2, so that's right here. And then I have to go down -4, so we're going to go down 1, 2, 3, 4. So that would be about right here. Okay, my next is at -1, -5. So here are my points, -2, -4, -1, -5, 0, -4, 1, -1, and 2, +4. So -1, 5 means I go left 1, down 5. So I'm going to go left 1, down 5. So that'll be right there. 0, -4, 0. I do not move left or right on my x. So I'm going to stay in the middle. And I got to go down 4 now because the -4 is going to go 1, 2, 3, 4 right there. Okay, my next and second to last is at +1, -1. So I'm going to go right 1 because that's +1. And I'm going to go down 1, which is at -1, right there. And lastly, I have +2, +4. So I'm going to go +2 on my x and then +4 on my y. Okay, now I plotted my points, but now we need to sketch it. What will it look like? Well, right here, I look like I go like straight up to this side. I can put an arrow. And then it kind of curves and goes back around. So I'm going to match that right there. And then I don't really know how it moves over here, but I'm going to guess that it goes up in this direction. Not entirely too sure, but that is what my sketch is going to look like. It's not going to look exact. It's going to look similar to what the graph would look like on an electronic graph, if we were to graph it. Okay, so on your Bellwork paper, I need the table and the sketched graph, please. If you already have those, go ahead and put those away in a safe space. And then on your way back to your seat, could you guys please get your workbook so we can finish our notes for Unit 3, Lesson 1.
Yeah, I was listening the entire time. I was just resting my eyes.
I saw you.
I like to do that. I like to memorize my answers and then just whatever you're doing, I'll just be like, I can do that.
Okay.
Is that yours? You didn't get mine?
Yes, 1 compass per table. So here it is. So if you guys can please get 1 compass per table. Actually, no, my fault. We already did the snowman, so you guys do not need that compass. The compass was for the snowman.
Forgot yesterday.
I forgot for this class yesterday, but I remember for the rest of my classes.
Yeah, because we're better.
Yeah.
You know what that means.
Alrighty, if you could please turn your page to, or your book to 311 for me. 311. Okay, once again, we are on page 311. We're going to be doing this, Are You Ready for More? Okay, you're going to need your ruler in hand, and you're going to need your writing utensil as well. Okay, so if you guys could please get those next to you.
10 times, but 311, are you ready for it? Come on.
Nathan, you have a ruler, sir?
Wait, do we need a compass?
No, no, you don't. You
Get
don't.
up, boy.
Hey, could you go ahead and
Gotta
get a
get
ruler
up.
for me, sir? Okay, if you do not have a ruler, I need you to please grab one.
I'm tired. I'm tired too. Well, we gotta do some math.
Alrighty,
Same
thank
thing.
you all. Alrighty, so yesterday we went through the introduction of what it means to scale something using dilation. Okay, we first looked at this hippo and saw, hey, in order to be non-distorted, everything has to be scaled the same, right? The height and the width. And also, we saw that the angles within our dilation have to be the same as well. Okay, and then when we were looking at how to perform the dilation, we see that we're given a scale factor, and we have all these lines that we use to increase or decrease the distance based on the scale factor. Okay, so for example, we took the snowman body and we shrunk it by a scale factor of 1/2 using these straight lines. Okay, so we're going to continue with that same idea, but we're going to simplify it with just a straight line instead of snowmans. So question number 1 is asking us to dilate the segment AB using the center P by a scale factor of 1/2. Label the results as A prime, B prime. Okay, so my R is equal to 1/2. What I need to do now is, do I have any information to use my scale factor at the
I
moment?
mean, AB equals 1/2.
Okay, AB equals 1/2 what? Inches. Okay, so Chase is in the right direction of where we need to go.
0.25.
We need to find the measurements of these lines. Okay, you said what, sir?
0.25.
For this AB?
Well, that's 1. 33.5. Sorry, half.
Okay, so it's 1/2 inch. So half an
Half of
inch,
that is
0.25 a quarter, right?
Yeah.
So where would I put that line though?
From A to B.
Where would I put my dilated line? Right, that's why
There.
we need to stick with those straight lines. Okay, so we need to measure from our center to our points. Okay, always measure from our center to our points. So from P to B, that is 3/4 of an inch. Okay, so 3/4 of an inch, PB is equal to 3/4 of an inch. Okay, what about PA? It's about 0.8 of an inch. So 8 over 10. So PA is equal to 8 over 10 inches. There's 10 points, right? So 1, 2, 3, 4. Oh, wait, no, there's not. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So this is 14 out of 15. So 14 fifteenths.
Yes.
My fault. 14
As soon as I heard
fifteenths.
the 10, I was like, huh?
My fault. I thought there was 10 little thing, but that's for the centimeters. I was mistaken. So 14 over 15 inches. So it's super, super close. And then Q what?
P to Q is 2.5.
Okay. Do we need Q right now at the moment? Not for number 1. We're just trying to dilate the segment AB. Okay, so our scale factor is 1/2. So what are we going to do?
Divide 3/4 by 1/2 and divide 14 15.
Not divide.
Multiply.
Multiply by 1/2. Right? Multiplying by a fraction is like dividing by the
I
denominator.
know, but it's the same thing.
Okay? I get you, I get you. So what I'm going to do is I'm going to draw a dotted line to my point A. Okay? And I'm going to go ahead and measure to half of what this needs to be. So PB was 3/4 of an inch, so that would be 3/8 of an inch. So that's going to be about, wait, how many? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 6. So 1, 2, 3, 4, 5, 6. So right here will be my B prime.
Wait, how did you find that?
Because I just found the halfway point. So from P to B, I counted each tick. There's 12 tick marks. So half of that would be 6 tick marks. Okay. I could have done it with the measuring of this, but 3/8 of an inch, not really easy to do with a ruler. Okay, next one, I'm going to measure from P to A and count in the middle. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 divided by 2 or multiplied by 1/2 is 7. So I'm going to count to 7 tick marks. 1, 2, 3, 4, 5, 6, 7, which is around right here. So there is my A prime. I can now connect these going straight down. Okay, and now Chase was saying that if we have a scale factor of 1/2, then that means that the distance between A and B might also have a distance of 1/2. So let's measure and see if that is true. So again, he used inches. He said this was about 1/2 inch. So from A prime to B prime, if Chase's hypothesis was correct, the A prime B prime should be 1/4 of an inch. So let's see if that is true. Ooh.
No.
Is it 1/4 of an inch?
Wait.
Kind of.
It is. I think it is.
Yeah, it would be, yep, it would be this longer side. So yes, this is indeed 1/4 of an inch. So Chase's hypothesis so far is correct. The segment that we dilate is going to have its distance reduced by the scale factor as well. So let's see if that's sorry, I'm seeing what the next question is. So let's see if that's true for our next one as well. Okay, so let's go ahead and go to question number 2. So it says dilate the segment AB using Q as a center at a scale factor of 1/2. Okay, it says label the results A prime, B prime. Okay, so from A to Q is about 1.5 inches. Or my fault, Q to B. So Q to B is about 1.5 inches. And from Q to A, it's a little bit longer than 1.5. It's I would say 1.6, yeah? So Q to A prime, or A, is equal to 1.6 inches.
Is that a cellular device I see shining in your hand?
Yeah, Shanae, can you please put that away? You should not
Put
be
your
on that.
phone away.
Can you open your book, please? We should be following along. Thank you. Okay, so I'm going to draw a dotted line from my center Q to my point A because we want that straight line to go across. Okay, our scale factor is 1/2, so we have to divide everything by 2 or multiply by 1/2. So QB, which is 1.5, divided by 2 will be 0.5 plus 0.25, so it'll be 0.75. So let's go ahead and measure 0.75 of an inch from Q.
0.75. That's just 3/4.
3/4, yep.
Right.
So right here will be my B prime. Okay,
And same thing with A.
same thing with A. 1.6 divided by 2 is 0.5 plus 0.3, which would be 0.8. So I got to do 0.8 of an inch.
1.75 to 3/4.
So 0.8 is about 80% of it, so it'd be about right here. And there is my A prime. Oh, yes, you're right. A double prime, B double prime. Thank you, Brinley. So let's look at these distances once again. So our original AB was 1/2. Is our A double prime, B double prime also 1/2? It is indeed. I mean, my fault, not 1/2, 1/4, as in our first time. So A prime, B prime is 1/4. A double prime, B double prime is 1/4. So they're both half of our original. Okay, so let's look at our last question. How does the length of A prime, B prime compare to A double prime, B double prime? How would the lengths of A double prime, B double prime change if Q was infinitely far away? Explain or show your answer.
Half of infinite.
Okay, so we see that no matter how far away our Q is, our distance in between is always going to kind of give us half of our scale factor, or half of our original thing, or our scale factor times our original distance. Okay, so explain or show your answer. Okay, so does anybody want to try to explain that? Why is the distance for Q not really matter about how far away we are from our original one?
Because we're not really measuring Q. It's more of the center.
Mm-hmm.
We're more focused on the center. We're not really focused on, sure, you need the measurement of it, but if it's infinite, you still have the measurement of it.
Mm-hmm.
I don't know how to explain it.
Okay.
Yeah.
So let's try to see if we could draw a picture. So I'm gonna draw, my original AB was right here, right? Okay, if I draw this all the way down straight, and I put a Q over here,
Can't you not extend it? It's not gonna work.
that's what the question asks. So what if Q was infinitely far away? So our center is Q, right, for this second question. So we're asking now, what happens if we put it further away? And that's what we're looking at the moment. So why do you believe we can't move the center?
No, I was just confused.
Oh, okay. So we can move the center if we want to. If we want to make sure that it matches later on, we have to stay on the same line though. So if I wanted to further out the Q, I would have to put it all the way out here.
Does it really matter what order you get all the measurements in, really?
Well, not really.
Yeah, as long as you just get them, all of them.
Mm-hmm. Okay, so this distance, I should have measured, but I did not. We're going to say it's 15. Half of 15 is 7.5. So 7.5 was right here. So this would be my prime. And then from here to here was about 15 point something, which would also be around right here.
So,
Okay, if I go straight down, again, this is half an inch. And then if we measure once again, yeah, this one will be a quarter of an inch.
okay, so in reality, you only really need to find one of them then, and then you just draw a straight line straight up, and then that's the other one, right?
For this one specifically, yes, because we have just a straight vertical line, so that made it easier for us to find that one, definitely.
Okay.
But if it was a more complicated shape, we would have
We
to
would
actually
have to,
go
yeah.
through with all the lines and do
But
that.
if it's like that, you can do that. You don't
Yeah.
need to find one and then directly go above it.
Okay. Alrighty. So we see that no matter how far away it goes, it's going to have the same property where it's going to be the scale factor times the distance. Okay, so from 1/2 to 1/4. Awesome. So good thing to know, right? No matter how far we are from our center, if our scale factor is the same, we're going to have the same distances no matter how far away we are. All right, let me talk about this summary, and then we're going to talk some practices, and then you will have your practice on your own. Hey, Canyon, if you want to give me that, and then we're on our workbook. If you want to grab that as well, please.
Don't forget about a ruler.
You're right.
Okay, so our summary. A scale drawing of an object is a drawing in which all lengths in the drawing corresponds to the lengths in the object by the same scale. When we scale a figure, we need to be sure all parts are scaled equally, or else the image will become distorted. We do not want distorted images. Creating a scale copy involves multiplying the lengths in the original figure by a scale factor. Okay, we're gonna underline that. So multiplying the lengths in the original figure by a scale factor.
I'm still going to say divide.
The scale factor is the factor by which every length in an original figure is multiplied when you make a scaled copy. Well, if you divide, what if you have a big number scale factor? Like, say if your scale factor is 3. Would you divide by 3 though?
No.
No. So,
But I'm still going to say, even though I mean multiply.
When you-
because it's a habit.
okay. So just make sure that you understand what you're meaning though,
Yeah.
okay? A scale factor greater than 1 enlarges an object. A scale factor less than 1 shrinks an object, right? We did that note in our previous one over here on question 1.2. We grow when r is greater than 1. We shrink when it's between 1 and 0. Okay, what does a scale factor of equal to 1 do? We talked about that. It's going to stay the same. Okay, so here's an example right here. They took BC and they scaled it. Oh, wait, no. BC is a scaled copy of DE. Okay, of 1/4. So DE should be 1/4. I mean, BC should be 1/4 of DE. Okay, so if DE was equal to 6, then BC would have to be equal to 6/4 or 1.5. To perform a dilation, we need the center and a scale factor and something to dilate. Okay, so a dilation with the center A and a positive scale factor K takes a point D along the ray AD to another point whose distance is K times further away from A than D is. Okay, so another example, segment FG is a dilation of, so FG is a dilation of DE using A as a center again, but this time it's a scale factor of 3. So FA, right here, F to A is 3 times D to A. So if DA was equal to 15, then AF would have to be 3 times 15, which is 45. So we're multiplying the distances times our scale factor. All right, so let's look at these practices in the book before we get to your guys' individual practice on Alex.
Oh, we're doing our practice on Alex today?
Yes.
Yeah, because that was low-key like getting my brain like...
Okay, so number 1. Okay, this is on page 313. If you guys could please turn to page 313.
What? But you just said we don't know Alex.
Oh, we're going to do a couple of these together.
Oh, well, because number 1 is making my brain trip out. Number 2
Okay,
as well.
so polygon Q is a scale copy of polygon P. What is the value of, well, the value of X is 6, so what is the value of Y? So how did they go from 3, or from 4 to 3? What did they multiply by? Oh, you guys can't see that, sorry.
From 4 to what?
What do you have to multiply by to go from 4 to 3?
0. That's just 0.75, right?
Okay, so what I'm asking is, so 4 is multiplied by some instrument to be equal to 3.
0.75, right?
So if we divide both sides by 4, our question mark will be equal to 3/4.
Which is 0.75.
So 0.75.
I was right,
Yeah, you're right. You're right.
immediately. I was like, what?
Yep, I'm just getting. How do we get that answer though?
Oh.
Right? That's what I was trying to show you guys. You were correct
I
though.
was like tripping. I was like, what?
Sorry, I was gonna confirm that right at the end. Okay, so if X is equal to 6, what is Y going to be equal to?
You just multiply 6 by 0.75.
So you multiply 6 times 3/4.
I think it's 5. No.
6 times 3 is 18. 18 divided by 4 is not a whole number.
Yeah.
All right, it'd be 18 over 4. Is that a whole number?
No.
No, because 12, 16, 17, 18. So it's about 4.5. Yeah, it's about 4.5. So the Y would be equal to 4.5. Okay, what is a scale factor? We found it. It was our question mark, right? What did they multiply to get to that smaller size? This would be our R is equal to 3/4, or our K is equal to 3/4. Okay, R and K so far have been what they've been using as the variable for scale factor. So that's what we're going to have to use as well. Okay, let's look at question number 2. Oh no, I marked myself.
No.
Okay, if figure F is a scale copy of figure E, so here's F, here's E. So E is the original, F is a scale copy. We know that AB is equal to 6, CD is equal to 3, XY is equal to 4, and ZW is equal to A. Select all true equations. We want to solve for A.
Okay, so we need to figure out how 6 got to 4.
Yeah, so how did 6 get to 4?
4.5.
Okay.
Divided by what? We got it on the last one.
Got on the last one. This one's a little bit more tricky, right? Okay, so if we look at their answers,
It looks like big heroes.
they have 6 over 3, 6 over 4, 3 over 4, 6 over 3, 6 over 4, and 3 over 4. Okay, and if we look, right? We need to compare what is on the same position. So which distance goes with AB in our copy? XY. So we need AB to go with XY. Okay, but let me ask you this. So we have 6 goes with 4, right? And 3 is going to go to A. And they have to have the same scale factor in between, correct?
Yeah.
So that means that they have to have the same simplified ratio.
So it has to be.
So if we look at this, we have 2 options. We can do 6 over 4 is equal to, the one that goes with 6 is which number? 3. So 3 is going to be on top, and A goes with 4, so A is going to be on the bottom.
Yeah.
So which one of our answers looks
There's B.
like that?
There's B, but I don't know what
B?
that is. Yeah.
Good. Now this actually isn't the only one that is true. We could also flip all of this and have it be 4 over 6 is equal to A over 3. Which is which one?
None of them. E.
It's not
There's
E.
6. There's
So all of them have 6 on the top, right?
Yeah.
Okay. So both
we
of these would get you the correct answer. Right, 4 over, yeah, both of these will get you the correct answer. It just depends on if we're going from the smaller ones to the bigger one or the bigger one to the smaller one, but you're always going to get the same answer for your A. So the only one that's true for this one was going to be B.
Wow, I don't want all these equations, bruh.
what are we doing right now?
Alrighty.
How am I gonna use this?
I'm beating my head against the wall.
If you're in art or something, you use perspective quite a bit to do like 3D landscapes and stuff like that. When you're dealing with, let's say you're in construction and you want to make a bigger door, so you got to keep the same ratios for everything to be bigger. Things like that, like you might not use this specifically, but using the idea of proportion and similarity in your head is going to be, you will use that later on in your life. Like, is this going to be big enough, or do I need to make it bigger? Or can I, so like clothes, right? Clothes are definitely proportional, right? Small, extra large, large. They're all the same t-shirt. They're just different size, right? They have the same proportions though. So we see proportions quite a bit in our world. We just don't really recognize them that well.
Don't break it away.
All right, so
No, no, here.
your guys' practice is in your Alex. Okay, so at this moment, there's only about 5, 6, 7. There's about 7 minutes. Okay, I'm gonna let you guys relax for that 7 minutes. Okay, but I want to show you guys where you find your Alex practice. Okay.
It's not in the same spot.
It is. It is. I just want to show you what it's called and everything. All right.
And we're doing this tomorrow.
And this will be our first thing that we're doing tomorrow after our bell work. And then after you're done with this practice, you guys will have your time for your cool down.
Give me that Welch.
All right. So once you guys get to your Alex topic, all you have to do is click on your assignments tab. Okay, let me get signed in. Yeah, Trippy still got about 5 minutes, so don't need your backpack.
I don't know. I don't work at all this week.
Oh, other than Saturday and Sunday. Other than that, I don't work.
Because I called in quote unquote sick one day.
You might get fired now.
What am I going to miss out on?
All right. So if you guys could look on the board just real quick. So tomorrow, you guys will be doing this practice problems, okay? So there's 7 questions. Would you guys like to preview what you guys will be doing?
Not really.
Well, I remember it is.
I'll figure it out tomorrow.
Okay, so there's 7 questions. This is what it will be looking like. Okay, you won't get the same question, but you'll have something similar. So it says right here, in a scale model of a boat, 1 inch represents 9 feet. Okay, so the answer the following. In a scale model, the length of the boat is 10 inches. What is the length of the boat of the real boat? Right, so 90 feet. So you multiply by that scale factor, right? So this would be 90 feet. Okay, the height of the boat is 63 feet. What is the height of the boat in the scale? 7 inches, right? So you have to do the opposite. You have to go the other way. We went from the big one to the smaller one. So this would be 7. Okay, we can check. Nice. So I'm going to go ahead and continue. Okay, and then another thing, same thing with this. What is the scale factor? The model goes from 4 to 14, 10 to 35, 12 to 42. So what fraction do we multiply each time going to from the model to the bridge? Right, so right here, modeled from the bridge. Oh, wait. To get the model from the bridge. Oh, my fault. We're going from the big one to the small one. So we need 14 over 4, 35 over 10, and 42 over 12. 42 over 12. So this is going to be like 7 over 2. Oh no, it should be the other way, right? We want to get smaller, so our scale factor should be smaller than 1. So let me check that. Nice. Okay, I just took the fraction and I simplified it when I got to my answer. Okay, so these are the questions you're going to have. You're going to have something with on graphs, questions to just look at, okay? So dealing with scale factor, but just in a different environment. So that is what we're going to be doing tomorrow. And then once you get 80% on this at least, you guys will be getting your cool down, which is what is graded.